Hello dear students, good morning to all of you. Welcome to you all on the IMS Gate Academy platform. In today's class, we are going to continue continuous time LTI system. We'll discuss about the convolution operator. As you know that in the previous classes, we have already started convolution topic. In today's class, we are going to discuss some PYQs, previous year gate question based on the convolution topic. So first of all of you guys just confirm audio and video. My voice is clear to you. Hello Priyam, good morning. Other students should reply whether voice is coming to you properly. You are able to see, screen is visible perfectly, board, smart board, everything is clear. So student, this is also we have discussed in the last classes. E to the power minus AT UT yes. So you know that the result is nothing but sir e to the power minus at minus e to the power minus bt upon b minus a whole bracket close u of t. Now guys you should reply this standard form you remember or not. And if you remember the standard form, I am asking a next gate question to you. So dear student, just do reply in the chat box whether the screen is visible to you or not, so that we can go for next. चलिए so let's start. So student, the next gate question is here based on the same concept. Here you need to tell me what is the answer. The given two continuous time signals xt equal to e to the power minus t, yt equal to e to the power minus 2t, which exist t is greater than 0, the convolution zt equal to xt convolution with yt, the result is equivalent to what? So simply you need to just apply e की power minus t convolution with e की power minus 2t. Both are the t is greater than 0. It means both are can be multiplied with ut. Both are right side signal only. So the answer will be e to the power minus t, e to the power minus 2t. Here a value is 1, t multiple, b value is 2 here, a value is 1 here. So b minus a means 2 minus 1 into u of t. So this is nothing but your final answer. So your final answer will be look like this, e की power minus t, e की power minus 2t ut, because 2 minus 1 is nothing but 1. Now all of you guys just do reply fast. Shall we go for next? Guys? Chali. So I think this question you guys can solve it easily. Thiru, good morning. Chali. So now student, here we have a next question that is directly we can solve by using the step response property, and you know that step response property says that if xt equal to e to the power minus 2t ut plus del t minus 6 is applied to an LTI system with impulse response ht equal to ut, the output is. So first of all student, examiner is asking for yt output. We know that which is nothing but a convolution of xt and ht, which is nothing but a convolution of xt and ht. So when you will convolve guys, what you will get, because step response property says that if you are convolving any signal with a pure step nature, here ut is a pure step nature guys. So I am writing x of t as it is and convolution with ut here. It means what? Whatever the signal we have, we just need to provide a integration, and because both the limits are right hand side, so minus infinity से लेके t, here you can apply x to d to, and this is nothing but the step response property. Step response property says that guys, if you want to convolve any signal to a pure step nature, then you just need to integrate the other signal with limit minus infinity to t x to d to. So it means if I will apply the limit here, actually my question is e to the power minus 2t ut plus del of t minus 6. So this term if I will apply minus infinity से लेके t integration with respect to d2, then what you will get? I am having space here, so I am writing here finally. So the second term, we know that the running integration of the impulse signal is always a step signal. The running integration of impulse signal is always a step signal, so it will be actually ut minus 6. And the remaining part you can directly integrate here, so you will get actually e to the power minus 2t upon minus 2t upon minus 2, and limit goes to what guys? Minus infinity to 0. Or even because both are ut, so both are right side signal ut, so the because of this ut, the lower limit will be 0 actually, and the upper limit will be remain same, that is t. So when you will apply the upper limit and lower limit guys, you will actually get 1 by 2 outside the bracket and 1 minus e to the power minus 2t and plus u of t minus 6, and that is exactly mentioned in which option guys? You can see here. You can see here 0.5 1 minus e to the power minus 2t ut minus 6, option number D for Delhi exactly. Exactly it is mentioned in the option number D for Delhi. 0.5 matlab 1 by 2 outside the bracket. Okay, so ut plus 6 you can directly ignore because the integration of del t minus 6 should be ut minus 6 only. बोलो बच्चों, yes or no? चलिए. So now we should go for next. All of you guys just do reply fast. Shall we go for next? चलिए. The next question is here. A linear time invariant system with the impulse response ht produces output yt when input xt is applied. When the input xt minus tau applied to the system with the impulse response ht minus tau, the output will be. So what we should write guys? Yt as a, we should write yt as a xt minus tau convolution with h of t minus tau. So ultimately what it will be, the convolution property says that you should add both the limit should add whatever shifting we have provided guys, the shifting will reflect in the final result as well. So the question starting like this कि sir, if xt convolution with ht is equal to yt, then xt minus tau is nothing but y of t minus this minus tau and minus tau मिलके क्या बनाएगा? Minus 2 tau. So it is yt minus 2 tau. It means option number D for Delhi. So this is simply a convolution shifted property guys. You can also apply the Laplace transform here, because if you will apply the Laplace transform you will get like this xt minus tau convolution with h of t minus tau. So when you will take the Laplace transform you will get e to the power minus tau s into x of s. Convolution in time is nothing but multiplication in frequency, so it is again e to the power minus tau s dot h of s. So now ultimately you will get e to the power minus 2 tau s and x of s into h of s मिलके बनाएगा बच्चों y of s. So ultimate when you will take the inverse Laplace, when you will take inverse Laplace transform, you will ultimately get yt minus 2 tau. So this is nothing but your final answer, y of t minus 2 tau, option number D for Delhi. However, the Laplace transform is not required because directly you can apply the convolution shifted property as well. Directly you can apply convolution shifted property as well. Yes or no, bacha? Chali. So other students will also reply. Shall we go for next? Chali. So the next question is here. The impulse response of a system ht equal to tut. This gate question we have already discussed in the previous lecture. Tut ramp signal and step function. We know that the convolution of ramp and step will be the parabolic. So I am writing here tut convolution of ut minus 1, convolution of ut minus 1. So ultimately actually it will become, when you will convolve the ramp signal to step signal, you will get the parabolic nature, but the shifting property is there. So ultimately it will be t minus 1 का whole square by 2 into u of t minus 1. So I hope this part is crystal clear to you beta. I hope this part is crystal clear to you. Shall we go for next? Chali. So my next question is here. The response ht of a linear time invariant system with the impulse response del t, then ht value is given to you. Ht value is e to the power minus t plus e to the power minus 2t. The response of this system for the unit step input ut is. It means examiner is asking that yt you need to generate y, and yt is nothing but the convolution of ht and ut. So here you can simply apply the step response property. Why we can apply the step response property? Because we know that whenever any signal convolve with a pure step nature, then you just need to provide a integration to the other signal, and because the other signal is given that e to the power minus t minus 2t, so we'll simply integrate 0 to t e to the power minus t plus e to the power minus 2t into dt. So this is nothing but my final answer now. Okay, so because it is given that initially relaxed condition, so he's starting from 0 only, so that is why. Now students, just apply the upper limit, lower limit, you will get the answer. So when you will apply, you will actually get e to the power minus t upon minus 1 and plus e to the power minus 2t upon minus 2 whole bracket close 0 to t. So when you will apply the upper limit now, you will finally get what, guys? You will finally get minus e to the power minus t and again minus 1 by 2 e to the power minus 2t minus upper limit minus lower limit. Minus lower limit means you will get this bacha, minus 1 and minus half. So now ultimately what you will get? You will get here minus 3 by 2. So it will be plus 1.5 and minus e to the power minus t and minus 0.5 e to the power minus 2t. So this you will get. I hope this is clear to you. So answer is nothing but 1 by 1.5 minus e to the power minus t minus 0.5 e to the power minus 2t ut. Option number C for Chennai Super King. Correct answer is C. बोलो बच्चों हाँ या ना? Yes or no? So this is the electrical 2011 gate question based on the convolution topic. All of you just let me know. Shall we go for next? All of you guys just do reply fast. Shall we go for next? Chaliye. So now student, the signal xt and ht shown in the figure are convolved to yield yt. Which of the following figures present the output yt? So if I talk about yt, my yt signal is nothing but xt convolution with ht, x of t convolution with h of t. Yeah. And you know that here the xt signal is containing pure step nature, so it is very easy for us to write the equation. So when you will write the equation, you will get del of t plus 1 and minus del of t minus 1. Yeah. This is the equation of x of t. And this is my h of t, guys. So if you are looking for the output yt, you just need to convolve x of t and h of t. You just need to convolve xt and ht. So when you will convolve, what you will get, guys? I am just writing here yt equal to, yt equal to h of t is as it is, and convolution with x of t. So what you will get? You will get h of t as it is and convolution with x of t. What is x of t, guys? Del t plus 1, we should write here, del of t plus 1 minus del of t minus 1. Yeah. Del of t plus 1, del t plus 1 minus del t minus 1. So ultimately when you will convolve, what you will get? You will get the result yt as a ht convolution with del t plus 1 is nothing but ht plus 1 and minus h of t minus 1. Yeah. So this is nothing but my yt, ht plus 1 minus ht minus 1. Yeah. So now student, what you need to do, ht diagram is given to you. First of all, you have to perform ht plus 1. It means we are having positive half shifting. We have to shift the signal in the left hand side by one distance. It means this signal when you will shift in the left hand side, you will get minus 1 to plus 3. You will get the limit from minus 1 to plus 3. So it will be minus 1, it will be 0, it will be 1, it will be 2, it will be 3. This is respect to t. Similarly, student, ht minus 1 also you are making. So do you know ht minus 1 is nothing but right hand side shift. So now the signal is going to be shifted in the right hand side by one distance. So now the midpoint will be, this is my 2, this is my 3, this is my 4 and this is my 5. So this is the diagram of h of t minus 1. And this is the diagram of ht plus with respect to t. This is also with respect to t. Now student, if I will perform time reversal, amplitude reversal, sorry. If I will perform amplitude reversal here, then I have to shift, I have to just make a mirror image with respect to x-axis. So if I want to include the negative sign as well, then my curve of minus h of t minus 1 will be what? Minus h of t minus 1 curve will be look like this. When you will perform reversal, you will exactly get curve like this here. So it will be 1, it will be 2, it will be 3, it will be 4, it will be 5 with respect to t. So now this is my ht plus 1 curve number 1 and this is my minus ht minus 1 curve number 2. Now I have to add or subtract because minus sign is already there. Because minus sign now already there, so I just need to add. I just need to add now finally. So when you will add these two curve guys, ultimately what you will get, you just need to check the location. So when you will adding these two curve 1 and 2, first of all from minus 1 to plus 1 what will happen? Before minus 1 to here minus 1 to plus 1 we have a 0. 0 plus something is something. It means whatever the linear nature, this nature will come automatically for the same. So it means from minus 1 to plus 1 we have a linear nature of the signal just like this. After that you have to think that sir, from 1 to 2 or from 1 to 3 we have a minus 1 line slope. And here what is we are having? From 1 to 3 again we are having the slope of, what is the slope of this guy? This is 1. Slope is minus half actually. This slope is minus half. And this line slope is also minus half because in that x-axis you are traveling 3 distance. So when minus half slope and minus half slope line will add, then ultimately you will get a decreasing ramp only, but it will have a slope of minus 1. It will have a slope of minus 1. It means from 1 to 3, 1 to 3, 1 to 3, you will make 1 to 3 you will make a ramp signal which is having the slope 1. Right now what is the slope of this line? So slope of this line is plus half. But right now you have to make a line which is having the slope minus 1. Minus 1 slope, it means from 1 to 2 distance it should travel 1 distance, and from 2 to 3 again it will travel 1 distance. It will travel again 1 distance. I hope it is clear. Yeah. So now this value is also minus 1. Now after that what will happen guys? After that, after 3 we don't have any signal here. After 3 we don't have any signal here. After 3 we have here plus half slope, plus half slope, and we have to make a ramp signal just like this. So this is nothing but 5, it is nothing but 4. So this is nothing but your final curve y of t, my dear student, and you have to check in which option it is given. So it is already given in the option number D for Delhi only. It is only given in the option number D guys. It is only given in the option number D for Delhi. I hope it is clear. I hope it is clear to you. Yeah. चलिए बच्चों, so if you want that we will have a continuous signals and system series, then at least you have to make yourself regular in the classes guys. Okay, so you have to be regular yourself, otherwise no meaning of the classes. Okay. चलिए guys. So I think now we are going for the next. चलिए. So this is the very good question actually, guys. Here we have convolve two signal as well as we have addition of two signals also. Chaliye, so next question, electronics 2017 gate question. Consider the parallel combination of two LTI systems shown in the figure, x of t, h1 t, h2 t, yt. So the impulse response of the system are, here we have h1 t also, h2 t also, but we know that if the impulse response are in parallel, we have to subtract or we have to add depending on the sign. So here which sign we have, guys? Here we have a positive sign. So ultimately I can make the simplified diagram as a, so this ht is nothing but actually h1t plus h2t, and from here actually x of t is coming, and here you will get y of t. So now ultimately what we need to do, we just need to convolve. So yt is nothing but x of t convolution of h1t plus h2t, h1t plus h2t. So when you will convolve it, what you will get? You will get yt equal to xt convolution with h1t and plus x of t convolution with h2t. Yeah. So this is my y of t. Now first of all you need to see ki what is h1t, h2t, you just need to add it. So when I will put the value of h1t and h2t here, actually what I will get? I will get my yt value equal to xt as it is, and convolution with h1t, it means twice of del t plus 2, twice of del of t plus 2, twice del t plus 2, minus 3 del t plus 1, minus 3 del of t plus 1, bracket close. And second time you have to again convolve this x of t with del of t minus 2, del of t minus 2. And do you know what is xt? It is given that xt is nothing but ut. Okay. So we'll update the xt value in the last tab. First of all, I am just updating here convolution with shifted property or even distribution property. So I will get twice into x into t plus 1, t plus 2, because this t plus 2 directly shift with t. So you will get actually twice into xt plus 2. Again you will get what, guys? Minus 3 into x of, again you will get what, guys? Minus 3 into x of t plus 1, minus 3 into xt plus 1, and again you will get plus x of t minus 2. You will get plus x of t minus 2. So this is the final curve you will get, guys. This is the final curve. Here you need to, this is the final mathematical equation. Here you just need to replace the xt signal as a unit step signal. You just need to replace xt as a unit step signal. So you will get finally yt as a, you will get finally yt as a, wherever is x you need to replace with ut. So it will be twice into ut plus 2. It will be twice into u of t plus 2, twice into u of t plus 2, minus 3 into ut plus 1, minus 3 into u of t plus 1, and plus u t minus 2, plus u into t of u of t minus 2. So this is nothing but my y of t, guys. Now student, you can only solve, you can only find the energy of the signal yt if you are able to make the mathematical curve. So just make a mathematical curve. All of you guys just make a mathematical curve. How many of you know how to write mathematical curve? You just need to check the nature of the signal is step only. Now only two parameter you need to check. One is magnitude and one is location. So plus 2, it means the location is nothing but minus 2. So we have to start the step signal which is having the magnitude plus 2, and we will start this signal with the minus 2 value, and we are waiting for the next change. So next change will occur at minus 1 location, but this time we have a change in magnitude minus 3. You are already present at plus 2 right now, you are traveling at plus 2. Now as soon as this minus 1 value will come, you will have a minus 3 step. So actually you will reach at minus 1. So now you are traveling at minus 1, you are enjoying at minus 1, but you are looking for the next location where the change will happen. So here two location. At two location we have a plus 1. It contributed plus 1 step. So right now you are traveling at minus 1. When you will add plus 1, you will reach at 0 only, and after that remain at 0 only. So now this is your y of t, and examiner is asking for its energy for you. Examiner is asking for energy, and you know that how to calculate the energy. It's very easy to calculate the energy. We just need to apply the a square into b, because here is the We have a rectangular pulse. So a square into b, here also we will do a square into b. So when you will do a square into b, you will actually get 2 square into minus 2 to minus 1 distance, it is 1 only. Minus 2 to minus 1 distance is 1 only. Similarly, here also we will get, so a square, so minus 1 ka whole square into minus 1 to plus 2 distance is 3. So again the answer is E equal to 2 ka whole square 4 plus 3. So energy of the signal is nothing but 4 plus 3 is nothing but 7. Correct answer for this question is nothing but 7, guys. Correct answer for this question is nothing but 7. All of you guys just let me know, shall we go for next? चलो बच्चों. So we'll be very happy if you will share the session link so that other student will also can participate, because there is no meaning of the live session. So now when you will reply and when you will message, then only we'll having the live session again, guys. Okay. So you guys can follow on the, you can join the Telegram group. You can search Ankur Sharma sir name on Telegram. You can just join Telegram group. You can also join, follow on the social media. You can also join the Telegram group mentioned in the description. Okay, so you will get the information whenever we have a live session. First of all, just do reply this. You all guys completed this or not? Okay. So student, now this is all about the convolution part. We'll discuss about this eigenfunction also, eigenvalues also, and LTI system with sinusoidal input also. But okay, in today's class we'll solve this question last because I am getting no response. So we'll meet in the next upcoming class, but this is the question we'll solve it last. The unit step response. If the unit step response of a network is 1 minus e to the power minus alpha t, then its unit impulse response will be what? Student, if the step response is given to you, you can easily find out the impulse response, because the impulse response is nothing but the differentiation of step response. The differentiation of step response. So it means impulse response is nothing but step response differentiation. So d by dt step response is nothing but 1 minus e to the power minus alpha t. So ultimately when you will differentiate, you will ultimately get minus, and again you will get minus alpha e to the power minus alpha t. So impulse response will be look like what, guys? So this is your impulse response. So minus minus plus alpha e to the power minus alpha t ut. So this is nothing but your impulse response. So alpha e to the power minus alpha t, option number A for Ahmedabad. Mehtaj, why you are not replying? Beta, you are attending the class regularly. Mehtaj, Sabreen, do reply, beta, do reply. You are getting this or not? So that we can go for the next concept. Mehtaj, Sabreen, just do reply if you are listening. Just do reply, guys, if you are listening this. Otherwise, we'll meet in the next class, okay? So I think one of the student, Vedai, is regular attending the class, but today she has a semester exam. So Vedai, once you will come, you can reply. You can just join the Telegram group. You can write in Telegram group, okay? So we'll again start the classes, okay? Chaliye. Okay, guys. So Those who are looking for complete structure preparation of the GATE 24-25, you guys can join the IMS GATE Academy. Okay, you will have a daily live classes. You will have 800 plus live lectures here. You will have 4000 plus practice question, 130 plus test series. Okay, you will get 26 to 30 hard copy of booklet, that is theory book and exercise book. Okay, बच्चों चलिए चलिए. So those who are watching the session, just reply in chat box. Just reply in chat box. Satyavardhan, hi beta, hi. So those who are attending the class, just do reply in chat box so that we can continue the next topic. Sabreen and Vardhan, you are attending the live classes, beta. You have also watched the recorded sessions or not? So do reply fast. Hi Syed beta, hi sir. Chaliye, very good. So now student, we'll start the next question. We'll start the next concept as well. Okay. You should parallelly reply it so that we can go for the next. So here the concept is exponential as eigenfunctions. Continue sir, Anshu. Very nice, very nice. So here exponential such eigenfunction. So student, if I talk about this concept, we have a continuous time signal. If the signal is x of t, if the impulse response is h of t, then yt. A signal is said to be eigensignal if output will be a scalar version of its input signal. It means output can be a k into x of t, then this k is actually working as an eigenvalue. It will be working as an eigenvalue, and this x of t will be working as an eigensignal. This will be working as an eigensignal. So what you can say that those signals are said to be a eigensignal. Those signals are said to be a, sir, how LTI say linear time invariant system don't have the initial, because beta if they have the initial value, they have a constant value, it will become non-linear na. Anshu, it will become non-linear na beta, yes or no? Are you asking for the last question? Yes or no? So for the linear time invariant system, we should not have any constant value addition. Suppose that initial value is -2 or initial value is -1 or initial value is +2. So whenever we'll have a addition of constant term in the system equation, it will make the system non-linear. So it means in the continuous time LTI system, in the CT LTI system, continuous time LTI system, we have a fundamental one eigenvalue, that is nothing but a e to the power j omega t. It means if I will apply this signal as a input, I will get the scalar version of its input signal only as the output. How I will get? I will just let you know. So Maitri, Satyam and all of you guys reply, you are listening or not, just do reply fast, so that we can go for the next. Chali. So student, now I am going for here. Now here if I will take my signal x of t as a e to the power j omega t, and I want to check whether this signal is actually working as an eigensignal or not. So how to apply? I am just applying the convolution formula, because I know to generate the output we should apply the convolution. So yt is nothing but xt convolution with ht. And you know that convolution formula is commutative, so I can also apply the formula just like this. Instead of x tau, I can write h tau dot of x of t minus tau into d tau. So student, now here when you will apply this, you will get minus infinity to infinity, h of tau will be as it is, and here what you will get xt minus tau, it means a will be outside only, and here you will get e to the power plus j omega, and t is nothing but a t minus tau into d tau here, into d tau. So ultimately when you will open the bracket, so a is already outside, inside the integration minus infinity to infinity, h tau e to the power plus j omega t and e to the power minus j omega tau, whole bracket close, here you will get d tau. So ultimately now what you will get guys, a into this e to the power j omega t term you can take outside the bracket. So e to the power j omega t is already outside the bracket. Now what is left inside? Minus infinity to infinity h tau dot e to the power minus j omega tau d tau. So it means what is this value, guys? So now this is nothing but the Fourier transform formula actually. We'll discuss in the upcoming classes. So now it is working as an a e to the power j omega t dot h omega. Yeah, dot h omega. So it means now a e ki power j omega t, don't you think this is nothing but my input signal? This is nothing but my input signal x of t. So what I have seen here, my output yt is also the my output yt is also the multiple of the input signal xt. It means now for sure this signal is actually working as an eigen signal. This working as an eigen signal for all types of continuous time systems. And h omega is nothing but this is actually working here as an eigenvalue. Yes. So those who have listened the last 10 minute, if you have listened carefully the last 10-minute concept, I am showing you the next gate question, and I want to see how many of you are able to solve. So shall I show you the next gate question, guys? So just try to solve this gate question. Tell me, guys, which option is correct? Fatafat se. Which of the following is an eigenfunction of the class of all continuous time LTI system? Which one of the following is an eigenfunction of the class of all continuous time LTI system? Come on, guys. So simply, sir, e ki power j omega 0 t ut, not ut is required, only e to the power j omega 0 t should be there. So earlier I took a can be 1. Correct answer option number CSK, Chennai Super King CSK. So e ki power j omega 0 t is my final answer, which is working as an eigen signal for the same. Now here, student, one more question is there. Electrical 2018, you have to solve this question first. All of you guys just do reply. A continuous time input signal xt, x of t is an eigenfunction of an LTI system if the output is. So you should check the output yt is nothing but, as I already told you, kx of t. Yt is nothing but kx of t. Why? Because if output is a scalar version of input or multiple of input, then the multiplicand factor will be working as an eigenvalue. So here k is an eigenvalue and x of t is working as an eigen signal. So why here h omega term is mentioned, e ki power j omega term is mentioned, so that a general student, innocent student can confuse. Okay. So if you have the pure concept, you can solve this question easily, and it is a pure conceptual question, no calculation is required here. Simple conceptual question, that is why it is a 1 marks question. Okay. Chali. So now we are going for the next question. It is a very good question based on the eigen value and eigen signal concept. The question says that the output of a continuous time LTI system is denoted by T system, a signal ZT. This is important line. A signal ZT called eigen signal. It means you are applying ZT as an input signal, okay, of the system T, where T ZT equal to gamma ZT. Now if ZT is a input signal, then gamma is a multiple of input signal. So gamma for sure working as an eigenvalue. Here it is also mentioned that gamma is a complex number, and general it is called an eigenvalue of the system T. So system is represented as a capital T. So suppose the impulse, this is very important line, suppose the impulse response of the system is real plus E1. It means your HT function impulse response is nothing but real plus E1. It is also given the statement. An examiner is saying that which of the following statement of true. So whenever such type of question will come, like which of the following statement, in that particular question, the solution is actually depending on the options. So you have to check the options carefully. Cos t and is an eigen signal, but sin t is not, or both are eigen signal. So it means examiner want to check whether cos t and sin t are actually working as an eigen signal or not for which LTI system which is having the impulse response real and even. Okay. So it means one by one we have to check for both the input. One input is cos t, other input is sin t. So one by one we have to check for both the input combination. So I am checking here. So student, if I will check with x of t as a cos of t, with x of t as a cos t. So if I will check for xt as a cos t, then my output result will be yt equal to minus infinity to infinity. Here what I will get, guys? Here I should write h of tau. Here I am writing h of tau. So yt is nothing but minus infinity to infinity h of tau dot of x of t minus tau into d tau. So now ultimately if I will apply this, I will get minus infinity to infinity h of tau dot. I will have cos of t minus tau into d tau. So now ultimately what you will get? You will get minus infinity to infinity h of tau dot, h of tau dot. You can open it, guys. You can open it. So cos a minus b. So you will have cos a into cos of tau, cos a cos b plus sin a sin b. So you will get here sin of t dot sin of tau whole bracket close. Here you will get d tau only. Here you will get d tau only. I hope this part is clear to you guys. I hope this part is clear. So ultimately what you will get now? You will get minus infinity to infinity h tau. You will write cos t here. You will write cos of t here actually. So h tau into cos tau into d tau and plus. You will ultimately get here minus infinity to infinity. Now this time sin t is outside. Now this time you can take outside sin t. So inside the bracket you will actually get h tau into sin tau into d tau. Yeah. So now finally student, what you will see here that h tau function is real and even. So when this function is even, this is also cos t function is also even. So even into even is even only. So this value will remain exist, sir. But this is what? Even, and this is sin tau is odd. So even into odd is nothing but odd, and we know that whenever we will integrate from minus infinity to infinity for any odd signal, we'll always get the answer 0. So the final result of this integration is actually equal to cos of t is actually equal to cos t from minus infinity to infinity. Here I should write h tau dot cos of tau dot d tau. Now ultimately this is my output signal, guys. So now you need to check whether the cos t is working as an eigen signal or not. So you can clearly see कि sir, here I have taken this xt signal as an input signal, and the eigen signal concept says that if you are providing xt as an input signal and if you will see the output yt is a multiple of input signal, then that particular input signal xt will be referred as an eigen signal. It means, sir, we can clearly observe that cos t is multiple of this particular part. So of course yt is a multiple of input signal. Input is nothing but cos t. So 100% cos of t is an eigen signal, or is working as an eigen signal. Is working as an eigen signal. Is working as an eigen signal. So it means for one option we have already checked, that is for cos t. Similarly you can check for sin t as well. And what about this? If I talk about this circle, this white circle value, so actually this complete term is actually behaving as an eigenvalue. This complete term is actually working as an eigenvalue. So for cos of t I have already checked. Now it's time you have to check for sin t. So if I will check for sin t, what I will get? If I will check for sin t, so now x of t equal to is nothing but sin t. The process will remain same. It means I can write yt equal to from minus infinity to infinity. I should write here x tau dot h of t minus ka tau into d tau. This is my convolution formula. But I know that convolution is nothing but commutative. So I can also use this formula. Even I should write here only. So I should also use this formula yt equal to minus infinity to infinity. This time h of tau as it is, and x of t minus tau into d tau. Why I have written like this? Because I know that it is commutative. So now I am applying this, because this time I am checking for the input xt as a sin t. So this time h of tau will remain as it is, and you will get this sin of t minus tau into d tau. Yeah. It means this is my y of t, guys. It means this is my y of t. Yeah. So now ultimately what you will get as a yt? You will get as a yt equal to, from minus infinity to infinity, what you will get, guys? H tau into, when you will open the bracket, what you will get? Sin a minus b. So you will get sin t cos tau minus cos of t into sin tau d tau. Yeah. So this is the equation yt you will get. This is the equation of yt you will get. Now finally, if I will open the bracket, what you will get? What you will get, guys? Just do reply. Yt equal to, you will get as a minus infinity to infinity. This you should open the bracket. So h tau. So you should write sin t outside the bracket only. Sin t will be only outside. So it will be actually h tau into cos of tau into d tau. And again here also you can take outside minus cos of t. So inside the bracket you will get minus infinity to infinity h tau dot sin tau dot d tau. So you know that, student, because h tau is given as real plus even. H tau is given as real plus even, and cos sine function is nothing but odd, and we know that even into odd is nothing but odd. So when you will integrate the odd signal from minus infinity to infinity, it means actually you are calculating the area of an odd signal, and we know that the area of odd signal will be always 0. Area of odd signal will be always 0. So ultimately your yt will become what, guys? Your yt will become what? This is my sin t, and minus infinity to infinity h tau dot cos tau and d tau. Yeah. So it means this is my y of t, this is my yt. So now I can prove that xt is equal to sin t. Xt is equal to sin t is my input signal. So this is presenting at the input signal, and this is nothing but my eigenvalue. Sin t is nothing but working as an eigen signal, and this is also nothing but eigenvalue. This is nothing but also eigenvalue. Yeah. Eigenvalue. Chaliye. So it means, what is the answer? What we can say that if you will observe clearly the eigenvalue, then you will get to know that both the eigenvalues are same only. Here also minus infinity to infinity h tau cos tau d tau, and here also minus infinity to infinity. Here also the same, minus infinity to infinity h tau cos tau d tau eigenvalue. Here also minus infinity to infinity h tau cos tau d tau eigenvalue. And both cos t and sin t are working as an eigen signal. So now which option is correct, beta? Option number D for Delhi is absolutely correct. Both cos t and sin t, are eigen signal. Cos t and sin t are both eigen signals. With identical eigenvalues. Cos t and sin t are both eigen signal. I am writing again. Cos t and sin t are both eigen signals. With identical eigenvalues. Yes or no? Chali. Okay, guys. So just do reply fast. You are attending the class in live manner or not? Okay. So student, once you will attend all the classes live, once Veday will come, once the other students will come, you can just write a message on 9079330095. Okay, whenever you will free from the semester exam, whenever you have 5 to 10 students, those who are looking for to attend the signals classes, those who want the signal live classes, you can just write a message on 9079330095, so that we will plan the next chapter number 2 for you. So as of now, chapter number 1 is completed. Okay, chapter number 2 I will complete once I will have a request, once I will get the request from your side. Okay, so chapter number 2 is nothing but continuous time Fourier transform, continuous time Fourier series, that we are going to not start tomorrow. I will wait for the students. If we have at least 5 to 7 students, those who wish to attend the session in a live manner, then only we will start the sessions. Okay, guys. So that's all from today's session. Those who are from nearby Bangalore area, you can visit our IMS Gate Academy, Bangalore, 3rd block, Jayanagar Center, Jayanagar 3rd block. And if you have any doubt regarding your gate preparation, you can directly contact to us, student advisory team. You will get, my dear student, once you will take the admission at the IMS Gate Academy, you will get 800 plus live lectures. You will get 12 mentorship my plan session. You will get 26 to 30 hard copy of booklets. You will also get 130 plus test series. You will also get 4000 practice questions and dedicated doubt solving portal. Okay guys, so that's all from today's session. We'll meet in the chapter number 2, but chapter number 2 will start if and only if you all are messaging me the number I have already given to you. Okay guys, so that's all from today's lecture.